Hello, my name is Laura Modelli, and welcome to Science for Education, supporting teaching and learning in science education. In this video, we are going to discuss series and parallel circuits. In the previous video, we talked about electric current and electric circuits. If you didn't watch it yet, you may have to watch it first before you continue this video. Now, before we continue, first, I would like you to know that there are components that we can add to circuits that limit the flow of current, and they are called resistors. Just like their name suggests, resistors provide resistance to the amount of charge that can flow. Resistors are made from materials that can conduct electricity, and most common resistors are made from metal, carbon, or metal oxide film. In our circuit right now, the light bulb is an example of a resistor. There is a thin wire filament inside the bulb that restricts the amount of charge that can flow. In the previous lesson video about electric circuits and electric current, we talked about a closed circuit and an open circuit. The simple light bulb circuit that had a battery, a switch or a breaker, and a light bulb connected by wires is also called a single loop or a series circuit. In other words, in a series circuit, all elements are lined up on a single path without making a branch or a secondary path. Therefore, the electric current that passes through one electrical component must also pass through the others, since there is nowhere else for it to go. Now, what happens if we put more light bulbs in the circuit in series with the others? Or what happens if we add more resistance in the circuit in series with others? The voltage or the potential difference energy that pushes the current through the circuit decreases as the current passes through resistors. The evidence of this is that the light bulbs go dimmer than when there are fewer light bulbs. What happens to the rest of the light bulbs if I disconnect one light bulb from the circuit? The rest of the light bulbs are off because the circuit only has one path for the current to flow from one terminal of the battery to the other terminal. Now imagine if you connect all the light bulbs in your house in a series circuit. When you turn one light off, the rest of the lights in the house will be off as well. For our convenience, we can use another way of connecting the bulbs to avoid that kind of problem. So instead of making a single loop or a series circuit, we can make more than one loop, making it a parallel circuit. In other words, let's split up the current into different paths. The flow divides and later rejoin. What happens to the light bulbs now? The light bulbs did not go dimmer because the current that flows in the circuit is divided, therefore decreasing the resistance to flow and making the energy potential difference that pushes the current to flow stay the same. Which one of these two types of circuits is best for our household needs? Parallel. Household circuits are always wired in parallel to ensure that different appliances can be added to or removed from the circuit without affecting the voltage available to each appliance. In the United States, every house receives between 110 to 120 volts from the electric companies. So, using parallel circuits, the electricians make sure that every room or outlet in the house receives the same amount of energy or voltage, so no light bulb will go dimmer in one room than the other room. And in case one light bulb burns out or breaks, the other light bulbs can still be on. Thank you for watching this video. I hope you guys enjoy watching this video and learning about electric circuits, series and parallel. See you in the next video.